Let's continue our study of dimensional analysis. I like to provide general equations, which some students like, some students don't. But let's go ahead and do that for this one. The general equation for dimensional analysis, it's always going to be question mark, what we want, equals our given number over 1 times our various conversion factors. The conversion factors will be provided unless they're common things, like 60 seconds in a minute. So let's go ahead and read this problem. A student has entered a 10-kilometer run. How long is this in miles? We are looking for miles, so question mark MI. The only actual number given in the problem is 10 kilometers. And I'm going to put that over 1. The 1 is really just a placeholder to let me know that kilometers is in the numerator. I'm given my conversion factor here. I just have to figure out how to make it a fraction. We all know that something like 50 divided by 50 is 1. 200 divided by 200 is 1. And we need to get rid of kilometers. So since kilometers is on top, I have to divide by kilometers so it goes away. I'm going to diagonally drop. km is on top, km goes on the bottom. From my conversion factor, I know that the other unit is miles. And then I'm going to plug in my numbers. It's 1 mile for every 1.609 kilometers. If you want, you can cross out your like terms, just the units. So since km is top and bottom, it can go away, and it leaves us with just miles. I do the math, and I get 6.215. I want to round for sig figs, just like before. So my given is 3 sig figs. So I count over 3. 1, 2, 3. This 5 makes the 1 become a 2. And then I put my unit. Yes, there is an easier way to do this. However, this is a process that is going to get more complicated as the semester goes on. And in order to get full credit for problems, you have to solve them this way. Let's move on to the next slide. Using what we just did on the last slide, I would like you to try example number 2. Please pause the video and do this. Please check your answer. Notice that I took our given, which was 8.7 liters, and put it over 1. And then because liters was on top, I needed it to go on the bottom so it could go away. So I diagonally dropped. And then I just plugged in my conversion factors numbers. Because there's one number on top and there's one number on the bottom, I have to divide. I wanted 2 significant figures because of my given. And so I rounded my answer to 2 sig figs. Let's look at the next example. It's a little more challenging. Now we're looking at 2 unit conversions, so we're going to need 2 conversion factors. Let's go ahead and set this up. So I'm looking for miles per hour, and I'm given 452 meters per second. It's very important that you separate out these units. When I solve this one, I first focus on either meters or seconds, and then I focus on the other. So I'm going to start with meters. Since meters is on top, I have to diagonally drop it to the bottom. Looking at my conversion factor here, meters is being compared to miles, so miles goes on top, and then I plug in my numbers. So 1 mile is 1609 meters. Now, for my second part, what I'm going to do is just focus on seconds. Well, right now, seconds is on the bottom. so I have to get rid of it. To get rid of it, I'm going to put it on top. It goes diagonal from where it started. So since it's on the bottom, it goes up here. And since I'm looking for hours, it goes on the bottom. I plug in my numbers, 3,600 over 1. And then I can cross out stuff that is top and bottom. Meters goes away. Seconds goes away. And I'm left with miles per hour. Now, mathematically, you solve this however works best for you. I like to just take anything on top and multiply, and then divide by the numbers on the bottom and ignore the ones. If it's better for you to multiply straight across for both, and then divide, that's fine. So you go ahead, you solve the problem, and then when you round, you want 3 significant figures. It's always based on the given. And so when I round for this one, I end up getting 1,010 miles per hour. Okay. I would like you to try a problem on the next page, which is a little more complicated. We're going to do the first one, and then I'll provide you the answers for the others as well. We will be spending more time on this in class too. So you need a couple of conversion factors here. You need to know that 1 pound equals 454 grams, which would be given. You also need to know that 1 cubic foot equals 28,320 cubic centimeters. The answer to this is 62.4. Please pause the video and try solving this problem. Please check your work. You'll notice that I put 1 gram over the centimeters cubed for my given. Then I had to diagonally drop grams because I need it to go away. So since it was on the top, it went to the bottom, so I can cross off the unit. Then for cubic centimeters, it needed to go on top because it was already on the bottom. And I'm left with pounds over cubic feet. You do not need to cube anything here. The numbers have already accounted for that. So when you go ahead and do your math, you should end up getting, once you round for sig figs, 62.4. The answers to the other 2 practice problems are there as well. And again, we're going to be spending more time on this in class. Let's move on. Next, we need to talk about measuring temperature. Temperature is defined as the measure of the heat energy of a substance, and it's measured, of course, with the thermometer. There are a variety of temperature conversions. Okay. The main one that we actually use in this class will be this one. The Kelvin scale is the SI unit for temperature, and we're going to use that a lot. So Fahrenheit equals 1.8 degrees Celsius plus 32. Celsius equals Fahrenheit minus 32, then that quantity divided by 1.8, and Kelvin is Celsius plus 273. These equations, are algebraic, so you just plug in the number that you have and solve. Please pause the video and try the practice problems. Don't forget to round for proper significant figures. Please check your answers. For the first one, you needed Celsius, so you had to use the second equation. You subtracted 32 and divided by 1.8. For the second one, you had to use the first equation, so you took 45 times 1.8 plus 32. For the last 2, you were either adding or subtracting 273. Okay. Hopefully these were not too bad. in general, if you need most of these equations, they are provided. The only one you really need to memorize is the one that I have circled. Okay, let's move on. The last part of the chapter is directly related to density, okay, and specific gravity. Density is defined as how heavy an object is compared to its size. It's independent of amount. So we like to say that it's an intensive property. Intensive means independent. It's a ratio of mass to volume, and its units are grams per milliliter or grams per cubic centimeter. Again, hopefully this is something you've seen before. Density equals mass divided by volume. Over here we have a triangle. Instead of having to do algebra, you can use the magic triangle. You will need to memorize the equation or the triangle for the upcoming test. To use the triangle, you read the problem and you cover up whatever it's asking about. So in the example, it says, what is the density of an object? So you're looking for density. So in essence, you cover up D and you perform the math. So you're going to do mass divided by volume. I'm going to go ahead and do that here. 54.2 grams divided by 31.7 milliliters. I still use my sig figs. So I round here and I should end up getting 1.71 grams per milliliter for my answer. On the next slide, you'll have the opportunity to try some of these. Okay. Let's rewrite our triangle just so it's available to us. Mass is on top, then it's D and V. Okay. And what I would like you to do is try some of these practice problems. For the third one down, you have to know how to find the volume of a cube. Volume of a cube is always length times width times height. Okay. And for the bottom question, you have to first find how many milliliters it was through subtraction before using the triangle. At this time, please pause the video and try the practice problems. Please check your answers. I used a triangle for each one and then rounded for sig figs. For the third one down, you did have to first find the volume, so 6.2 times 6.2 times 6.2, and then I took my mass divided by volume. For the bottom one, I first subtracted the 2 milliliters provided, and then did density, which is mass over volume. Unit-wise, things that are kind of helpful to note, mass will always be grams, no matter what. Volume can be either milliliters or cubic centimeters based on the problem and how it's given. And then, of course, density is a combination of the two, either G over ml or G over cubic centimeters. Let's move on. We're going to briefly talk about something called specific gravity. Specific gravity is the ratio of density of an object to the density of pure water. Basically, it's equal to density, but has no units. So mathematically, the problems are solved the exact same way. You can just use your density equation. So in the example, it says, what is the mass of an object given this specific gravity and volume? You just have to remember that this is basically the density and solve. So mass equals D times V. So when I solve this problem, I end up getting 287 grams.